Yes. All right. Welcome to this new EESSI Happy Hour session. This is in the series of a peek inside the EESSI layers. And today the session will be about the compatibility and software layers. So we do this every Monday, same time. And yeah, again, I will focus on these two layers today. Just a short peek inside those two layers and tell a bit about what's going on there. Well, as you notice, the session is being recorded. At the end, we will stop the recording. So if you want to ask anything offline, which is not being recorded, feel free to wait with your questions till the end, and then I'll stop the recording. If you don't mind, you can, of course, also ask it while the session is still being recorded. Go to the next slide. So the highlights for today, the first bit of news items about EESSI and the multi-X skill project, which is where EESSI is being part of. First of all, the multi-X skill Center of Excellence will be part of the European Researchers Night. This means that on our online social media platforms, we will basically present members of our team, of the multi-X skill team, tell a bit about what they are doing, what kind of research they're involved in, or how they help out researchers. If you want to follow this, you can click on this link. That will, I think, lead you to Blue Sky, but as far as I know, it will also be shared on LinkedIn. Then another news item, the Euro HPC user days are coming up. That's on the 30th of September and the 1st of October in Copenhagen. And on the Thursday right after the user days, so the 2nd of October, EESSI will organize a hackathon session, which will be fully in the subject of CI/CD, so continuous integration, continuous delivery. For both aspects, EESSI is a very well fit, as we will show in that session. So there will be some kind of introduction to those topics. But in the afternoon, there will also be a more hands-on session where you can pick something yourself and design your own adventure of setting up CI/CD pipelines using EESSI. It's a hybrid event. You can either attend in person or online. There will be EESSI members around, also online. So if you want to talk to one of us about how to set up something, we can have a breakout room on Zoom, or you can ask that in the in-person session. You do have to register for the session. It's free, but please first register if you want to attend this. Then going to the topic of today. So I'll give a short overview of the compat and software layers, how that works, and what kind of versions we have, what kind of support both layers offer. So right now, as you may know, EESSI offers two different versions, 2023-06 and recently we added 2025-06. Both have their own compatibility layers, and the compatibility layer is a sort of operating system layer hosting all the operating system libraries. This makes the EESSI stack completely independent of the system that you want to use EESSI on. So it doesn't depend in any way on your host operating system. So that can be a Ubuntu or a Debian system, a Red Hat system, or whatever. As long as you can mount EESSI, all the operating system libraries will then be provided by the EESSI compatibility layer. This compatibility layer is built using Gen 2 prefix, which is a bit of an odd choice in the HPC world. As far as I know, nobody is using Gen 2 in HPC. EESSI is using it, and that's for a very good reason, because Gen 2 prefix is a Gen 2 project that allows you to install Gen 2 in a non-standard location. So you can basically pick any location where you want to install this OS, a home directory or any other directory. And this is a very good fit for EESSI because it allows us to basically ship an operating system in our CVMFS repository. So we basically ship it with the software such that the software will always be able to find these libraries and doesn't need to find them on your system. This is one of the only distros that allows you to do this, so that makes Gen 2 a very good fit for EESSI. Well, since we have two EESSI versions, we also have two different versions of that compatibility layer. The new one contains more updated libraries, or newer glibc, newer libraries, etc. Then we built each of these compat layers for the architecture families that we want to support. So in both 2023 and 2025-06, this is x86-64 and ARM64. And in 2025-06, we also added support for RISC-V in the compatibility layer, even though we don't provide any software on top of it yet, but at least the compatibility layer is already in place because that's sort of stable. Just a very quick overview of how that looks for the ones who haven't seen this before or have never gone into the details of the repository. If you go into one specific version directory of EESSI, you will find the compatibility layer, the software layer, and some additional initialization and scripts, which are being used for setting up the stack itself. But for now, we will focus on the compat layer. We only offer one for Linux clients, and then in there you will find versions for ARM and x86-64. Sometimes they get updated, and then we rename the old one in this -001, -002, just to make sure that we keep copies of the original directories. But in those directories, if you will go in here, you will basically see a standard Linux installation with the structure that you're probably familiar with. Same for ARM, which is basically the exact same operating system layer, but then built for ARM systems. And for the new version, you will see the same structure, except that there's now a third one in there, which is RISC-V. Also, that one will look exactly the same as the other ones for x86 ARM64. You will also see that start prefix script. That's something that Gentoo provides. It will just give you a shell inside that compatibility layer, and you can use all the tools from that compatibility layer as if it were a real Gentoo system. Note that we only provide one layer per family, so one for all x86-64 CPUs, because this doesn't really contain very performance-dependent software. So the actual software installations themselves, like GrowMax, TensorFlow, etc., those are not in here. Those are being built for specific CPU types. This layer has less critical components, which are not really sensitive with regards to optimization or specific CPUs. So that's why we only have one per family. Then for the software layer, we of course have those same versions, and then we built different compilers, different tool chains, as we call them. So that's the easy build concept, where this FOSS toolchain consists of the GCC compilers, OpenMPI libraries, mathematical libraries like BLAS and FFTW. And then we chose to make a split based on those toolchain versions per EESSI versions. So for the old EESSI version, we only offer right now FOSS 2022b, 2023a, and 2023b. And we're probably going to limit it to that. And then for the new version, we will add support for newer toolchains, so FOSS 2024a, 2025a, and maybe later on even more recent ones. That means if you want to contribute anything back to EESSI, so if you want to add a software package to EESSI, you will basically have to find the installation recipe in EESSI build, so the EESSI config file, and look up which toolchain that specific application is being built with, and based on the toolchain, you can then pick the right EESSI version. So if it's one of those older toolchains, you will have to add it to the old EESSI version. If it's a newer toolchain, you can add it to the new EESSI toolchain. So that's the sort of split based on the toolchains that we use here for the EESSI versioning. Then going more into the structure of the software layer or software layers. This is sort of the overview of how the directory structure of the software layer looks like. It's a quite nested structure, since we basically built the entire EESSI software stack, or every version of the EESSI software stack, for a whole bunch of different CPUs, because this really matters for the performance. For TensorFlow or GrowMax, you really want to build for that specific CPU type and make use of all the CPU features. So in order to do that, we basically kick off builds for every application for each of the 13 or 14 CPU targets that we support right now. So we have 13 CPU targets, which are sort of stable and all the same. We're currently finishing the 14th one, which is an ARM A64FX CPU. Once that's complete, we will fully support 14 CPU targets. So you don't see them all listed here. That wouldn't fit on the slide, but this sort of gives the overview of how that would look like. So under software, you will, so this path here, which I already shown in the terminal, you will find again a Linux directory because everything is built for Linux. And then the CPU family, so ARM or x86-64. And under there, you will find more nested subdirectories for specific ARM CPUs. And sometimes there's another subdirectory level with a vendor like AMD or Intel. And then under that one, you will find the actual CPU targets like Haswell, Skylake, Ice Lake, etc. In each of them, you will then find the sort of standard EasyBuild installation directory. So when you install something with EasyBuild, it will install the actual software into a software directory and then /TensorFlow/version number. And it will provide a module file in this modules directory, which will then end up here. So that's the same that you will find in each of these directories. Then when you're going to use EASY, you don't really have to worry about this nested structure and find the right software yourself. So all the initialization scripts that we provide and the EASY module files will take care of this. It will do an auto detection of the CPU type that you have on your client system, and it will then set up the module system in the right way. So it will configure all the right paths to the module files and to the software installation tree so that your system knows where to find those. In one of the previous sessions, we talked a little bit about how you could override this. So if you think you want to make a different stack available on your system for whatever reason, because you just want to test something or try something out or compare two different stacks, that's possible. I can provide that link in the chat, but we recently added that here to the documentation on the, I think it's in the basic usage menu here. In setup environment, then you get to this page, and on this page you will have a section here overriding a CPU or accelerator architecture. So that's being explained how with an environment variable you can sort of override the choice that's being made by the EASY initialization module. So you can force, for instance, that on your system you want to use the Haswell stack. And the same for an accelerator, to which I will get to in a second. So accelerators then, that uses sort of the same structure, but it makes it even more complex because you get an even more nested structure now. Also because the CPU and GPU software are sort of tied to each other. For instance, for TensorFlow, if you want to build a CUDA-enabled TensorFlow version, it has lots of CPU-only dependencies, and those are taken then from the CPU stack. But then you have to find the right match between CPU and GPU for your system. Ultimately, that would lead to a lot of different combinations, and that would mean that we have to build all CUDA-enabled software for all those combinations. Which makes it sort of impossible to support any given combination that you could create out there, which is why we chose the most popular ones and also the most popular and nowadays available GPUs. We built a bunch of those on native systems, which really have those GPUs, and we sort of cross-compile all the other ones. Also for this, you can find more in the documentation, but then the resulting structure looks like this. So you get the stack for the CPU again here under AMD Zen 2, for instance. But in there is also a subdirectory with accelerators, NVIDIA. That's the only one we override now, though we're working on AMD GPUs as well. And then we chose to, for now, support only these three compute capabilities, so three different kind of generations of GPUs. And we basically built all the CUDA-enabled software for those combinations. That already means that we have to support 13 CPUs times 3 GPU generations. So that's 39 combinations in total, which is already quite a lot of builds. But that's currently being built. And then in those... Yes.
Yeah, well, one remark here, Bob. You say we build only for these specific GPUs. That's actually not entirely true. The CC 80, for example, which corresponds directly with A100. So compute capability 8.0 corresponds with A100. But those same binaries will work fine on other GPUs of the same generation. So like A10, A40 will just be detected correctly by our init script, and they will pick up those binaries and they will just work. So in some sense, we're building once per generation of NVIDIA GPUs.
Yeah.
And Blackwells actually that are going to be interesting for Umid are not supported here yet, but we can expand that to also cover compute capability 10, which would be the Blackwell generation.
Yeah, thanks for adding that. So we're building for 39 combinations right now, but it indeed works for a lot more. And also for this, so as Kenneth already mentioned, the initialization scripts will detect and fall back to the right compute capability. If you want to override that, that's also being described on that same page in the documentation. So then you can pick another compute capability if you want to try that. I can very quickly maybe show, you can probably guess how it will look like. But if you really go into those directories, you will see that indeed here is that modules and software directory. Wait, where is Excel right now? Or am I missing one? Don't have that here yet.
What are you looking for?
I'm in the wrong version. No, I was looking for accelerated directory. I'm in the wrong version. So if you go into a Zen2 directory in the old version of EESSI, so we haven't built any accelerators for the new version yet, but there you will find those Excel directories, NVIDIA CC70, and then in there you will find the only CUDA-enabled software, which might have dependence or will have dependencies on the CPU stack, which is why you need to basically merge those stacks together on your system. But that's, again, something that will be done by the EESSI module. All right, that was the sort of overview that I wanted to give for today about the EESSI layers. For the next session, we're going to look into the EESSI GitHub repositories and have a walk through all the different repositories that we have. But for now, feel free to ask questions about what we presented today. Again, if you don't want it to be recorded, just let me know and we will stop the recording, and then you can ask your questions after the recording has been stopped.
So I have a question.
Yes, sure. Go ahead.
Would it also be an option to build the accelerated software for accelerators in the generic section of the EESSI software stack? Because you do have, let's say, a generic directory. Because, well, my philosophy, or not philosophy we have at Delft Blue, is that people are using accelerators for accelerating specific tasks. And it saves time, at least for me, to build only for generic architecture like Haswell, because most processors will support that anyway, and build accelerator stacks for specific targets. So what are your thoughts on that?
That would definitely be an option. I think we even discussed that when we were setting up the whole plan for building GPU software. We actually already also do that as well, as you will see.
Yeah, for generic CPUs, we already do it. Yeah, but do you mean generic CPU-wise or GPU-wise?
No, CPUs, just like Haswell.
We do this
version.
Already.
Okay.
We actually do these GPU builds for those 3 generations of NVIDIA GPUs for all the CPU targets we have.
Yeah,
so we have 13. Yeah. Well, and there's a good reason that there could be an extra performance benefit by using a CPU optimized, let's say, Python with a PyTorch that is optimized for the particular GPU. It is not impossible that you'll see speed up.
Yeah, in a specific case of Chromax, there's a clear split in the computation with respect to GPU and CPU. They actually complement each other there. So I would guess that for that kind of software, you need specific support for specific CPUs on the target. So it makes sense.
But you're definitely right that it would make our life a lot easier if we chose to just build only generic software and then build GPU software on top. I think we did at some point consider building lots of different combinations only for generic. So let's say the unusual combinations that we skip those and only build those on top of the generic CPU stack. But yeah, in the end, we decided to do it this way, build only these 3 compute capabilities for all the different combinations. And yeah, I think we will have to see how this works out. If it gets out of hand, then maybe we have to reduce the number again.
We have to buy more machines. And that's also...
Yeah.
Well, it's actually now we do 39 builds of every GPU software we install. So 13 GPU targets times 3 generations. If we add Blackwell to that, that would be, again, 13 extra. That's getting big, but it's not going to explode all of a sudden. But by the fact that we only build once for each GPU generation, and I think we're not leaving a lot of performance on the table because of that, it seems acceptable for now. We'll have to see how painful it is going forward. The one thing that have become very good at is automating all those builds. So that is actually the actual building part is not that painful. It's more the odd one out that fails for maybe a weird reason that we have to re-trigger and making sure the full matrix is filled. That's where things are a bit tricky currently. We can probably improve on that. But right now, we want take this approach and see what happens. The other alternative for some software doing only generic, CPU generic, and then GPU on top. And then for other software, do CPU optimized and GPU. I mean, the split would make it more difficult to manage. Doing the same thing for everything is actually helpful as well.
Yeah.
And there's probably downsides to both approaches.
Okay. Thanks.
We'll see how it works out. And I mean, we'll have additional easy generations where we can change our mind if it's too painful or not working well in practice. The project is called EESSI, but the people who, let's say, install all the software don't have an easy job. It's the end users that have it. Yeah, so that's...
I would have 2 questions, one short and one maybe a bit broad. Let's see if we can answer them. Support for the Zen 5 architecture, is there is this on the roadmap or?
Yeah, essentially it's on the roadmap. One open question we have there now is we haven't seen Zen 5 GPUs yet in AWS or even in Azure, I think. That's one of the reasons we're not doing those builds yet. We actually have in-house AMD Turing systems, so we could start building for them. It would be way easier for us if we could just add another type of system in our AWS build cluster and just enable it there.
Just technically, okay, go ahead. Just technically, you always build natively on the CPU target. You don't cross-compile.
For CPU, we don't cross-compile, no, because that again would be a nightmare in terms of making sure it's all good and correct.
Okay, so that's the reason why you have to wait until you get the CPU architecture to build it. And then maybe a second question along the lines. So if we want to have the base software layer on EESSI, but then maybe build on top of it our own software stack. I mean, we would like to contribute it obviously through making PRs either to EESSI config and then to EESSI, like it's described in the documentation, but sometimes we need the software a bit earlier. So there's some documentation how to set up kind of the same system as you do it on your pipeline on site, that we can somehow leverage the same pipeline to build the software on an NFS share, for example. Are there any best practices how to best do this, or do any sites, or is it supposed to only use EESSI, and if you want to switch to another software tree to basically only use them exclusively, either EESSI or the own software tree, or can we mix and match?
No, it's a very good question. We also had a tutorial specifically on this topic about building on top of EESSI. But it mostly depends on whether or not you're going to build on top of EESSI. So if you decide to build your own stack completely independent of EESSI, I would recommend to not mix them. So then you give users either access to the EESSI stack or some way to also get access to your own software stack. But EESSI provides a lot of mechanisms to build software and even a complete stack on top of what EESSI provides. There's a separate module that you can use, EESSI Extend, which is also documented in the documentation. That will basically set up the EESSI stack and the EESSI build modules for you with the same configuration that EESSI uses, but it only changes the installation path so that you can, for instance, choose to install in an NFS share or even in your home directory if you want to have users install stuff themselves on top of EESSI. Yes, thanks to Pedro for providing that link. So if you use that option, you can basically just merge your own stack with EESSI, and your users will basically only see one stack, and they won't even know if a module comes from, well, they can know, but they won't really see if that module comes from your own installation or from EESSI itself. And there's lots of ways how you can do this. You can also start using the same kind of build pipelines as EESSI does. So we use a build bot to do all the builds in a sort of automated way. Lots of sites have already taken that build bot and set it up themselves in such a way that they can use the bot in a similar way as EESSI does. So you can just build on your own systems with that bot and then ingest it to your software stack. That can be CVMFS again, like EESSI does. It can also be an NFS share or something else.
Okay, sounds actually pretty good. We will look into this. One more question, if I may.
Sure. Yeah.
So we were also thinking of maybe switching from the like lowercase non-hierarchical naming scheme on the EESSI config side to a hierarchical one. I just read somewhere in the blog that there might be a plan to expose different module naming schemes from EESSI. Right now, it's just basically flat, right?
Yeah.
Is this planned? And because then, depending on that, we will actually also align ourselves to the naming scheme that EESSI will use for the on-site software stack.
Yeah. Also a good question. That's definitely on the roadmap. Also because lots of people have been asking about this. Some people really don't like hierarchical schemes. Other ones really do like them. So far, EESSI has only been providing a flat scheme. But in principle, it should be very straightforward once we build the software to also build the module files in such a way that we can just provide different views or different naming schemes. So that's definitely something that we're looking into. I think someone is already trying to sort of loop through all the module files that EESSI provides and rebuild them with EESSI build with the flag module only, such that will basically just take all the installations that EESSI already has and only rebuild the modules for a different naming scheme. I think he was running into a few issues, which I don't know, Ken, maybe you know better if all of those have been solved. But once that's solved, it should be easy also for us to do a rebuild of all the modules and provide that in our repository.
I think the main thing there was actually a bit more tricky than you might expect. It's not about just using module only, but making sure that you use the same EESSI config, maybe even the same hooks that EESSI used when doing the original installation. So in practice, it's actually a bit more painful than you may expect. But we do have plans to not only have one view on the installations like we currently have with the flat scheme. We may do flat scheme, we may do hierarchical on side of that. We may actually do both Lua and Tcl module files as well, because we see sites that prefer not using LMOD, but want to use the Tcl-based environment modules implementation as well, which is currently impossible since we only have module files in Lua syntax. So we may actually have the same view, but with a different set of module files as well.
Okay, cool. One more question. So the release cycle for the EESSI versions is like 2 years. Maybe I missed this in the documentation. And also, I guess you will have only one toolchain version in every of those versions, right? You will not mix toolchain versions. So it's going to be either 2024A in 2025 EESSI, and then 2027 or 6 we'll have the next toolchain version, right? Maybe I missed
No, we actually do two tool chains per easy
Okay.
version currently, and three ones in the first one, but that may be an exception.
Mhm.
This may suggest a 2-year release cycle. I think we're now sort of aiming for a 1-year release cycle. So around May, June, kickstart another easy version, and then try to do that every year. So have a new glibc version, a new compat layer, and then whatever toolchains are next, dropping those into that new easy version.
Mhm.
And easy build, we already have 2025V
Mhm.
defined as a toolchain. I don't think there's a lot of value already jumping on that because there's not a lot of software there yet. But
Mhm.
it's quite possible this may land in 2506 as well. So we will have multiple toolchains per easy version. Yeah.
And you don't have problem because we had problems when we have also some kind of release where we basically install toolchains, and then I think maybe it's a setting in our environment module. Some users load a Python from a different toolchain, and then we get like a huge mess and software breaks. I guess this is you can probably control this with nmod environment module settings that you cannot.
Yeah, you can configure Lmod to not do these reloads that it
Okay.
Yeah, and I think that's what we do in easy. Yeah.
That's this default. Okay, good, great. That's it.
At least,
All my questions.
Yep. At least you get an error, then the user still may be confused. And this is actually a good reason to have something like hierarchical
Yes.
where you cannot easily mix.
Exactly. So we were thinking of if we have hierarchical, basically to have a meta module that will point down all the way to the leaf module, and then we can roll forward. Like we can have a latest that points to FOSS 2025, and then you see all the modules so that the user doesn't have to load first toolchain, MPI, library, and so on. So make it easy in that way. I don't know if Easy plans to do some meta module where you can say version and then I don't know, like that was our idea to solve the user problem. Yeah.
Yeah, that could make sense. I've also had a long-standing idea of actually without using hierarchical modules to still have sort of the same approach where once you load the toolchain, that everything else that's not compatible with that toolchain becomes invisible by default. You cannot actually load it that easily and not have this maybe weird structure of a hierarchical naming scheme. Yeah, but this has never been implemented to this point. I think it's possible just with an Lmod hook actually, and a bit of work. But yeah, there's definitely room for improvement there to have less confusion for end users. Yes.
Oh, cool. Yeah. Great. Thanks.
Are there any other questions? Or maybe, Richard, I didn't check the chat yet. Were there any questions in the chat that we can answer?
I think they're just comments and links to relevant pages in the documentation.
Okay.
Maybe one question about the CUDA software, the one we currently have, if that would run on Blackwell.
It would run on Blackwell. Yes, the CC90 would run on Blackwell, but you're probably leaving some performance on the table there because you're not using optimized CUDA or GPU builds that match that generation. So the Hopper builds that we have should work, as far as I know, should work on Blackwell. And I think what Umid was asking for the Turin, so that you're going to probably get Zen 5 AMD GPUs in that new system together with Blackwell. So what we have today already should actually work on that hardware. It will just fall back
to Zen
the AMD.
I guess.
It will automatically fall back to Zen 4, and I think it should also automatically fall back to the CC90 builds, so the Hopper builds.
So use the latest compatible version, like CPU and GPU architecture.
Yeah. The detection script is smart enough to do this. Yes.
One thing actually is, I remember, like because we were also looking into the Easy test suite just to run it to get a feeling of how Easy works, and then we wanted to run like from the head node like GPU tests, but I think this was the recent addition to the documentation. We ran into the issue that none of the tests were visible because I guess when you run the reframe test, it will check the architecture and there's no accelerator on the head node. So I managed to work around with the overriding of the accelerator architecture, just for people if they want to run the reframe, the Easy test suite. And how is so every new software gets a test, or is it like certain, I guess it's only certain softwares like Romax and like the big complicated software that gets tested, right?
It's definitely not every new software that would that would block us a bit too much. But whatever is sensible to write tests for is what we try to implement in the EESSI test suite. A big thing there is the tests in the EESSI test suite are portable in the sense that you can run the same test on other systems without changing the test at all. It is not
the system,
not
right?
common for everything. And that takes a bit of expertise, let's say, and a bit of work to implement the test in such a way that it works nicely across.
Would you say it makes sense actually to run those? I mean, they are tested. So, and if the software stack is portable, you could argue that it should also run on our side.
Yep.
Minus the, like, I don't know, hardware issues or some certain.
The detection. Yeah. Yes, they should work. If they don't work, it's definitely a red flag.
Okay.
All right. If there are no more questions, I guess we can end the recording, Richard, and to another check if there are any other questions.
Okay, so I will stop the recording.